Hello friends, welcome to Packet Pulse. Today we'll see how we can troubleshoot a packet drop issue on a corporate network. Let's take this example below, the diagram here as an example. So we've got a source and we have a destination. So normally on a scenario, when somebody comes to you as a network engineer or a network technician, they will provide you only the source and destination and they say, okay, I'm having packet drops. Please fix this for me. So what will be your first take? You take the source, you take the destination, you find out the device or the switch where the source is connected to. Okay, so you can do a trace, you can log into the switch, do a so MAC address, and find out, where the source is connected to. I'll make a detailed video about that on the next one, how you can identify where the source is connected to. If you're not aware, you can always write it down in the comments here. So once you know where the switch source is connected to on which switch, you log into the source. If the source is not accessible to you, you can log into the next hop from where the source is. Normally, it can be the switch. If you're a network engineer, servers might not be accessible to you. You might have access to the switch. You log into the next hop, the nearest device which you have access to. Okay. And then what you can do is you run a trace route. So when you run a trace route from, let's take, for example, that you have access to the source and the destination in this case. If you don't have access here, log in here and run a trace route. If you don't have access here, log in here and have a run trace route. As a network engineer, you should have access to at least the router and the switch point of view. Okay. So for this example, let's take that you have access from the source. So you log into the source, you find out where the source is connected, log into the source, and run a trace route. So when you run a trace route, it will show you hop by hop on what all devices are being passed through when the destination is reached. Like the source goes to the switch, and then it goes to the R1, R2, R3, again the switch, and then the destination. Okay. So what we have to do is normally the first step would be logging into the source and doing a ping, right? So you run a trace route, you found the path. Next is you run a ping, you run a constant ping to an extended ping to check, if you're getting packet drops or not. Yes, you will get packet drops sometimes, and if it's a constant issue, you will get packet drops on and off. Suppose you ping 100 times, you might get 20 packet drops out of 100 pings. So always ping more than 5 times. 5 is the default ping times that, when you run a ping command, it goes, but always ping more than 5 times because you'll not be able to find packet drops with a 5 ping or a 10 ping. So run more number of pings so that you will be able to identify if there's a packet drop or not. For example, you have found out, okay, there are packet drops when you're doing an extended ping. So what you have to do is first, you now we don't know where this is, right? So there are so many devices involved here. So we'll have to isolate each and everything. The first thing I would recommend is isolating the LAN part of the house, right? So this is, for example, the LAN part of the house. That means this is their internet router. Okay. So if this is an internet router, anything before the internet router that's going onto the internet is your LAN part. So you'll have to troubleshoot this part. So from the source, check if everything is fine. Here's the physical connectivity. In this scenario, just remember we are assuming that there has been no network changes or no changes on our side of the house. Okay. So if the changes we consider changes, the changes might be anywhere, right? So we'll assume that there has been no recent changes and the issue just started. So now we think we will troubleshoot first from the source of the switch if there is anything, any drops or anything. If you found the drop here, you can immediately you don't have to work on the whole path here, right? You see, okay, from the source, if any drops is there, you go to the switch, you check if there are any drops onto the source, you check if there are any CRCs incrementing, if there are input errors are incrementing. That's how you check the physical layer of the switch, right? So physical layer of the connection, or you're seeing any flaps on the network. So all those things you have to take into consideration on each and every hop. But first, start on the source, go to the switch, and clear till the internet router. Okay. And then once you are all good till here, then what you can do is you can take it from here to the destination. So once you prove that your LAN is fine, you go onto the WAN. You log into the router that connects to your ISP connection. So suppose this is your ISP connection, right? So you log into the router that has ISP. Okay, even if you don't have an ISP, it's an internal LAN that connects, one corporate sites to another. That's fine. So you have a dark fiber connection, so that's fine. But you log into the first router and then do a trace route from here again, or do an extended ping. So you go here, ping hop by hop from here to here, log into each and every hop, and then you'll be able to see where the packet drop is, right? So from here, if you're seeing you don't know where it is, but when you log into hop by hop, you will be able to identify where the packet drop is and then work accordingly. So once you log into each and every router, the first thing that you have to do is run a series of commands that helps you check the logs, that helps you check the time, the so clock, because you'll have to identify the timer and you're seeing the recent logs, and also you'll have to go and check if this interface status, right? So this interface status, let's look at this green. These interface connections that are connecting from one device to another are healthy. Like you'll have to go and check if there are no input errors, there are no CRC errors. You can always do a show interface and that interface name. Check if there are any input errors or CRC errors. I'll explain you on the next slide if what the interface looks like, a healthy interface, or how many CRC errors you can see if there are any issues on the network, right? Okay, this is normally how a SOA interface would look like. So when you do a SOA interface, and show interface command on the router or switch or anything, this is how it looks like. It will show you the interface name here. It will show you it's a hardware, what's the address. So remember this is the MAC address. Okay, the MAC address never changes. This is the MTU size. So this MTU size comes into a picture a lot of times. So even in packet drop issues, right? Whenever there's a source and you're trying to do a destination, everything seems to be okay. You don't see packet drops when you are pinging on a normal MTU bytes. But when you're pinging larger packets, so what's the MTU of a normal packet or normal interface? The MTU of a normal interface is 1500 bytes. So however, your packets might be bigger than 1,500 bytes. Your packet might be larger. So now what we have, what we do on this case is these big packets are called jumbo frames. Remember the term jumbo frames, right? So not, those packets are of 9,000 bytes. So if anything above 1,500 bytes is getting dropped on the network, that can be an issue on the MTU. So what you have to do is you'll have to log into each and every device and find out which device, check the interfaces on the path, check if any of the MTU sizes are smaller than what is expected, right? So when you do an extended ping, so IP, and then I'll share you after this what is the extended ping command. So when you do an extended ping, you can ping with a lesser byte. Let me share it to you right now. Hold on. So yes, this is what the ping command would look like, right? So what you're trying to do here is you're trying to ping from the router. You log into the router, for example, here, and you're using a ping IP, and then you're hitting the enter button. So the next option that you get is a target IP. Target IP is the destination that we are trying to reach. We can put the number of counts. So what I was saying is if you are troubleshooting a packet drop issue, do not use 10. You can use a minimum of 100. So 10, you cannot find out if it's intermittent. You'll every time you ping a 10, you say, okay, everything is good. But when you ping a higher number of packets, that's when the problem arises. This is the datagram size that we consider is the size of the packet that we push across the network, the size of the packet. So what this is directly proportional to the MTU size. So the MTU checks what is the size of the packet that is coming across the network. So here it's 200. By default, MTU is 1500 on most of the network. It will pass through. But if you put a 2000 here and then you do a ping, what happens? It will drop if the MTU size is 1500. So that's when you go into that interface and identify that interface where the MTU size is less and work on increasing the size of the MTU so that this will go ahead, right? So this is dependent upon application wise. So we'll have to work with the application on what is the maximum MTU size that is being allowed on the network. So network is normally the path, the road. So we should talk to the vehicle owners on what kind of vehicles they are bringing, what is the capacity of it. So if we do not know the capacity of a vehicle that's carrying, so we've got a small road, we're trying to bring a big truck in, that is supposed to fail. That's supposed to crash the roads. Either it's going to damage the road, or either the vehicles are not going to run properly as it's supposed to. So that is one of the points where what I wanted to bring in here, right? The diagram size. Yeah, timeout seconds is normally how many times it's going to wait before it says, okay, I am timing out, I'm not able to reach. So this portion is very important, right? Another thing is you give a source address or the interface. So you have this net router you're trying to reach here. If you give a default, there's one more default connection from here. If you don't give this source address, it will not take it will take the default route. But however, you say, okay, I don't want to take the source from this interface. I want this interface to be the source. So you give a source interface here so that this source is trying to reach the destination, whichever path it takes. Okay. I think that's pretty much it. So that matters. And yeah, these are the initial part of it. So please consider all these things while trying to troubleshoot uh, the basic part of how you do an extended ping. That's essential in identifying where the problem lies. So coming back to this interface description page, wherein we were seeing what the MTU size can do. So please consider that MTU size whenever you're troubleshooting a packet drop issue as well. So this is the bandwidth of the link. How much is the bandwidth of the link? Which are the important things that you should consider? Another thing here is a full duplex, right? So it can be a full duplex or hard duplex. Normally nowadays you hardly see any half duplex. So it's going to be either full or auto. It's auto normally means that it's going to negotiate on the other side. So whichever is, if it's the other side of the interface that it's connected to this guy, if the other side interface it is full duplex, it'll be full. If it's half, it's half. So yeah, we don't face too much of an issue, but this also is something that we can check. If there's a duplex mismatch, you will get packet drops, you will get issues on the network, you'll see flaps. That can be identified by logging onto the device and doing a show log. You will see a lot of duplex mismatch on the logs. Okay, another thing that we have to be very clearly, yeah, so I've already marked it here. So it's input errors, CRC errors, frames. These are the things that we should consider. So if the input errors and CRC errors are increasing, so it's normally an issue with the physical link. You have to check what's happening on the link end to end. Maybe replace the wires, replace SFPs, replace anything physical that's on there. For most of the times, there are issues with the cards as well. So yeah, it works out that way. So this is the portion that you have to check. This one also. So is it is it the input errors or is it the outgoing errors, the output errors that are increasing? So you can always check if it's incrementing or not incrementing. If it's incrementing, yes, the problem lies here. So if there is a redundant interface, suppose, for example, you have two links going from here to here, and you see there's an input error here, and there is all a backup link here. So the best practice is to disable this link so that all the traffic would flow through it and there is no customer impact. Yeah. And yes, before I forget, what is one very important thing is that duplex and link issue will be directly related to reliability. So now you see the reliability is 255 upon 255. So 255 is the max reliability that is on a network interface. So if you see anything less than this, yeah, 255, it will be an issue on the interface. It most probably is a physical issue, right? So whatever I've told earlier, you have to check on that one. Another thing that we have to consider is the TX and the RX. So TX is the transmit load, how much data you are transmitting from this device. RX is the receive load. If you do not have enough bandwidth on the link, so you've got a link here, your bandwidth is very less. What you will see is the TX, you will see this nearing to 255, right? So you are transmitting 58 here in this case, but you are receiving very less. So if any of these are increasing, it's going to choke the network. So that also has to be taken into consideration in identifying what the issue is. Either you are transmitting too much or you are receiving too much, and you are not able to get the link is not able to hold that much of data that's coming in. So transmit, receive, reliability, CRC errors, inputs errors, and all these things on the network here. This page would be very, very crucial for you to identify where the problem lies. So before I end, I would want to list the some of the commands that is very useful in identifying the issue that we're talking about. So we can always do the show log, which is very important command. So you'll know from when the issue is happening, what time it started, what all errors are you getting. So these are very critical in identifying any of the issues. So you'll have to see the logs. Logs are everything to you, remember. So logs will tell the truth. So if there is the log, somebody did something, you'll find out. If there is a flap on the log, you'll know what is happening. So these are critical evidences for you to work on with. The clock has to match the log, so you know how when the last log the flap, when you see the last logs. We also discussed about the ping command. The ping extended ping command is very important. So this is one of the way, and to run ping commands, there are numerous ways you can just play around with it, the network, and you can see. So interface, we discussed this in detail so that you identify what all fields are there on the interface, what all you can check to clear or identify where the issue is. Clear counters on the interface. If you're clearing the counters, you can monitor it again. So when the next you're clearing the counters, everything will be zero. Like the CRC's input, everything will be changed to zero, and then you can monitor again. You'll so when the last counter work cleared, and then you can work on it further and monitor the interface. So version, this will give you the what OS you are running on. When if there's a reboot on the device, if there's a reboot happened on a particular router or a switch, it will show you when it happened and when the last time it rebooted, since the last time it was rebooted. Traceroute is the first command that we discussed to identify how identify each and every hop, how the traffic is traversing. The traceroute will show it to you. Traceroute will also show you the time that it takes from this hop, this to here, again this to here. So we will discuss more about traceroute, but that's how, if you are not aware of that, please put it in the comment. I will be more than happy to make a video of how traceroute works, how ping works, and all those protocols, how it works, because those are basics are very important when we work or grow onto becoming a network engineer. Next, the final command, the master of all commands, is so tech support. If you go to a vendor, either you have a Juniper or you've got a Cisco, you've got other vendors, right? So they always want a tech support. The command might be different for different vendors, but they always would want a tech support. So this is a master command which gives you, the output of most of the commands tagged together. So log, so clock, all these, and there are n number of other commands. You can run that command. It Either the best thing to run a tech support is run a tech support and then forward it to our text file, right? Output.txt, so that this output you do not see on the screen. That output, whatever you see, actually goes on to the a text file wherever you want to see. You can give a double arrow, uh, the path and the file name like this, output.txt, so that the tech support file goes onto the text file wherever you want to save, and then you can have a look at it. Because if you type it on the screen, it will just go over. You will not be able to see everything. So I believe I covered most of the things that are needed to troubleshoot. In case I missed, I will try to add up again. And in case you feel there is anything additional information that was needed on the video, you can always comment. I will be more than happy to respond back as soon as possible. Yeah, once again, right, please do like, subscribe to my videos, and you can always post on the comment on what videos you want to. I would be more than happy to make videos for you. These all videos will be based on my practical experiences of a network engineer, and being on the network engineer and the development fields for more than 15 years. I would be, yeah, my practical experiences would be helpful for your understanding. If I do miss anything, as I say again, please comment and I'll be more than happy to respond. Thank you for watching.